This is going to work through the odd-numbered problems, the two odd-numbered problems, on the extension practice sheet for the two-variable inequality section. Okay, what makes this a little bit tougher is that it's not in the slope-intercept form, makes it slightly harder to graph. So our first goal is to take this equation and to solve for the y. All right, I need these x's to go over here to the other side. We're then left with 3y greater than negative 2x minus 15. We will traditionally put the x term first to match the slope-intercept form. And then lastly, division by 3. Now, because 3 is a positive number, no need to change the direction of the inequality. Negative 2 divided by 3 is just negative 2/3. And negative 15 divided by 3 is a minus 5. Okay, we are now in the slope-intercept form. Let's do some graphing. To start with, the y-intercept is at negative 5. So on the y-axis, put my first point at negative 5. For the next point, use your slope. So this means it's a negative, so I'm going to be going either right and down. So if I go 2 down and 3 to the right, so 2 down and 3 to the right. Problem, of course, is that's now off the screen, or it's off the grid, right? So let's do the same idea, but in the opposite direction. How about we go up 2 and then left 3? Just like this. Now, I've got 2 grid points. We can draw a line between them. So, taking a look here, I see it's a greater than, no little equal bar underneath, so I actually want the dashed line. So as I pick my line maker, just so I can get it nice and straight, I'm going to start with a solid and then change it to a dashed and adjust it. It's actually not that bad. I think I'm going to make it a little skinnier, make it dashed, and make it red. Okay, so what am I seeing? I've got this line. It goes through my y-intercept at negative 5. It's got that slope that goes either down to right 3, or conversely for us to stay on the grid, up 2 and left 3. What matters is when you're finished, you want to see that line going down. From left to right, goes down with that negative slope. Our final choice, we've got to decide where we want our shading to go. 2 ways to think about this. The first, if it's y greater than, that means I want to go above the line. So my shading will be up top as I switch to my highlighter to represent my shading. Going to be up above the line. Oops. We get the gist here as we fill all that goodness in. However, it is always a good idea to check by picking a test point and making sure you actually do solve the inequality. So I'm going to just denote here my test point. I'm going to use 0, 0 because it is the easiest test point to use. And when you are testing, always use your original equation. So this is my test check. I think that 0, 0, it's in the solution area. So it should give me a true statement. So 2x plus 3y, so 2 times 0 plus 3 times 0. Is that greater than negative 15? Well, that's 0 plus 0, which is just 0, which is in fact greater than negative 15. That checks out. Tell you what, why don't we also, just as a way to make sure that we did our solving okay, let's pick one that we think is not a solution. So for a second test check, maybe I'm going to pick, how about this one here? So negative 5, negative 3. So second test check. This one I want to be false, right? Because I picked a point that is not in the shaded area. So if I go 2 times the x, and the x is negative 5, plus 3 times the y, and the y is negative 3, I'm checking to see, is that greater than negative 15? Let's see. This would be negative 10 minus, oops, I did 3 times 3, and it should be 9, of course. So negative 10 minus 9, that's negative 19. Is negative 19 greater than negative 15? It is not. So this is a false statement, but that's good. That's what we wanted to happen. A point from the shaded region should make the inequality true. A point from the unshaded region should make the inequality false. All right, let's go again. Here we go, starting with x minus y greater than or equal to negative 3. Let's first move the x term over to the other side. And then, remember, when there's no number written, there's a little pretend imaginary 1 in front of the y. So let's, to finish, divide both sides by that negative 1. Be mindful that because I divided by a negative number, the number down below is negative, change the direction of the inequality. Negative x divided by negative 1 is just x. Negative 3 divided by negative 1 is plus 3. Here's the inequality we're working with. So first, y-intercept, and the slope. Once again, there's a little pretend 1 in front of the x there, which is really the fraction 1 over 1. So from here, go up 1, right 1. You can keep doing that forever, and you're going to get that nice 45-degree angle line going on. Let me get my line maker, just so I can make it nice and straight. I'm gonna, I think, extend that a little longer, make it a little thinner. This time, we want to keep it solid, since we have that equal to sign underneath. And there we go. That's my boundary line. In terms of direction, we're going to do the same thing we did before. This is a less than, meaning my shading should be below the line. But we're also then going to test check a few points. And forgive me, I know I bled over a little bit above the line there. The highlighter is kind of hard to aim. So thank you for your understanding. But that's the idea. Now let's do a couple of test checks. First, let's check one we think should work. Now, easiest one to pick, 0, 0. So let's see, is 0, so test check, is 0 for the x minus 0 for the y greater than or equal to negative 3? Well, that's 0. Yep, 0 is greater than or equal to negative 3, so this works out. Now a second test check. How about this one right there? Now I like to pick a point on an axis if I can, because then at least one of the coordinates is 0, and that makes it easier to work with. So this is 0, 5. So 0 for the x minus 5 for the y. I'm going to actually leave some space, call it the second test check so we know what's going on. Second test check. So a 0 for the x minus 5 for the y. Is that greater than or equal to negative 3? Well, that's negative 5. No, negative 5 is less than negative 3. This does not work. But again, that's good. That test check point I picked was in the unshaded area. So this should not be a solution. So the fact that this is a false statement is an indication that we have probably done things okay.